Hello everybody, welcome back to some more live coding. Tonight's topic is going to be Rust for file forensics. Now, when I say file forensics, I don't mean anything too sexy. I basically listed out the agenda here. So, I'm going to try and knock out as many of these as I can in one sitting. And so we're going to start with some very basic file forensic kind of things, like getting the metadata about a file, opening and closing files for reading, dumping hex values, looking for ASCII characters in a binary file, looking for specific file signatures like images, looking for large files or recently changed files, and then maybe seeing if there's a library to pull Exif data from images, and if we got some time at the end, we'll look at some steganography things where you're basically hiding data in images. So, let's get started. I'm going to use IntelliJ IDEA for this. They have a Rust plugin that works very well. And so I'm going to put this inside the cookbook. And I'm going to use the Rust cookbook. So I've already got several little code projects here from previous streams where we learned how to use Rust in general and did a couple things. So what we've got already are channels, taking command line arguments, cowsay, cross-compiling, file IO. Okay, so I already do have a simple file example. And then what else do we have? The hello world, making an HTTP request, linking with C. Yeah, so we did linking with C libraries and how to use WebAssembly, which are very, very similar, actually. Basically, linking with the C library, you're linking with an external library. That's exactly what you're doing with Rust and WebAssembly. You're using JavaScript to call an external library written in Rust that's compiled to WebAssembly. So the idea there is actually almost identical, but in different roles. Anyway, we've also got some multi-threading and a little packet capturing example. TCP client, TCP server, and wrapping a C library. So slightly different examples for wrapping the C library. And so if we look at the one where it says wrapping the C library, we basically call external lib C, we tell it what the library, the external lib is, and then we define the external function. And in the linking with C one, we've done the exact same thing, but we also wrote the C library ourselves, just to make sure we really understood, okay, we can compile a file, like how do we compile the library ourselves in C and actually link it to Rust and all that. So did all that, and those are the examples we have, and now we're going to work on some of these file ones. So let's look at the file IO one that exists already here. Okay, so we've got the main function, path new, and a path to a file. Let mutable file equal match file create. I forgot what the match does. File create, okay. You got the error and the okay. So let's use that as kind of a starting place. So let's start with the top one, getting date stamp and metadata about a file. So to start a new Rust project, you do cargo new, and we'll just say get file metadata. That'll be the name of the application. So now it's here, and if we go open the main.rust, now we can say, okay, attach to this new project we created. Okay. And so the goal here is going to be getting the date stamp, size, the permissions, the metadata about a file. So what we want to do is take a file name as the first parameter, as the first CLI argument. And so the goal of all of this is really as an exercise in Rust, for one, but also to be building blocks for later on down the road. So if you're a security professional, a penetration tester, a forensic investigator, something like that, these building blocks will help you write your own tools when you need to do things. So these are some of like the very basic kind of tasks you do when you have a file or you're looking for a file on a hard disk or something. So they're not the most complex examples, but hopefully it's a collection of relevant pieces together. So let's see, Rust file, what are they called? Crates. Okay, so here's the official documentation for the file. So let's pull up the example first for the command line arguments. Okay, here we go. This is the little chunk that I want to take. What else? I'm also going to need this other crate. So we need to get the standard environment crate so that we can pull the arguments. And actually what we want this to be is the file name. We're going to have to say let args equals args collect. Okay, hold on. Okay, so let's make this bigger. We're going to start by creating a vector of strings, and we're going to get that from this function, the environment args.collect. So then we have all the args in a nice vector of strings. And so let me see, is arg0 is going to be the file name itself? Or yeah, so when I say file name itself, I mean the program, the executable program. So 0 is going to be the program, and file name should be the second one. And then after that, we'll say maybe print usage. Close. Okay, so let's give this a test real quick. And actually, we're going to have to create a function called print usage. And we'll say something like usage, and that's going to be args. Well, let's come back to that, an example. We'll print out the example usage later, but let's just try it out. So I think we can do cargo run. Yeah, so we can just do... Oh, I'm in the wrong directory. So let's go into our new project. This one is the get file metadata. And we'll do cargo run. Okay, it's going to compile, and it's going to complain. Oh no, it just gave me warnings. A non-snake case. Oh, okay, I was actually wondering about that. So the standard naming is more like a Python lowercase with underscores as opposed to camel case. And yes, thank you. I should use the refactor instead to do that for me. Okay, so now we see no file name arg provided. Good. And if we do 0, we can confirm that it does actually. Let's see. Otherwise, so if we do that, we also want to exit. So Rust system exit. What's the function call? Sys standard process exit. Okay, and so if it's not provided, we actually want to exit. We want to print the usage and then exit. Okay, and then we want actually the error. So yeah, now let's do 1 and try this again. and then echo out was there error code? Yes, exited 1. Good. So perfect. And it prints out the example usage. Cool, so now we have a little framework for a program where so print usage, where is it here? And let's pass in the args. And then let's take in the args like that. And then we can say, let's see, what's the equivalent of the printf? How do you print formatted in Rust? Funct? Oh. They have it named funct, kind of like... Okay. Oh, I think I can just do it right in the print line. It's kind of supported by default, I think. So here I want to say usage. And then I want to put the file name itself. That's what I'm trying to do. So that's going to be args.get0. Hold on. No, because that's going to give me an option that I have to unwrap. So maybe not. Why don't we just call it? We'll just assume it's such a small program. We're just going to assume it's got the right name. Get file metadata and then file name. Example, like this. Get file metadata. This is an actual example usage. Okay, like that. That's, you say, okay, I want to get the metadata on the SSH config file. So let's try it out in the terminal and just make sure it looks good. Yep. Okay, now what is this? Unused variables? Oh yeah, because I was trying to print out the arg of the actual file. So actually, why don't I just take in the file name here? Executable file name. And so that's actually going to be args.get 0.unwrap. Shoot. This whole option thing is still a little weird to me. And we'll take that in here as a string. That's going to be the executable file name of type string. Now is it? Yeah, it's a capital S. Yeah, so I have to do... Now I forget, okay. I found address as string. There we go. I think that might do it. There we go. So now it automatically, when you print out the usage, it automatically outputs whatever the executable file name is. So if you compile this to be called get metadata instead of get file metadata, then it's automatically going to print out your file name, as opposed to this hard-coded value here. Okay. So we should be good there. Our print usage is all done, and it'll print usage and exit, and that'll be nice. That'll be nice and helpful later as we write more programs later. We can reuse a lot of this logic for printing usage and exiting and checking arguments and stuff. So why don't we create a function actually called check arguments? And then let's put all of this in here. Okay, we're going to make it inside a function called check arguments, and this is going to basically make sure that all the arguments are provided. Okay, so if it's not, it's going to exit, but if it is good, then we can say filename.unwrap, and we can return that And since there's only one argument, we can go ahead and just take. I guess it'll be let file name string, or I guess it's going to be an address of a string, a pointer rather. Return, and then it's probably complaining because it doesn't have the return type here, which is going to be a string. I think you got a colon. Wait, how do you do it here? Oh, what's the syntax? I forget. There it is. Arrow. Yeah, Buzzmin Kunhun says, I. Hello. Maybe you meant hi. So, hi. Welcome. Welcome to some Rust. Some very basic Rust. We're gonna build up though. This is just the boilerplate stuff. We're only gonna have to kind of do this once, and then we can copy and pasta a lot of it. Don't tell anybody I said that though. So this is just a way for me to kind of try and clean up the code so that the main actually looks decent. So we're going to check the arguments at the beginning, which is actually going to check them and return them for us. There's probably a package. Now, what I would suggest if you're making like a more full-featured program, there's probably a package out there to parse the arguments for you in a more robust way. So let's kind of explore real quick. I'm not going to use any. I'm going to just kind of go with my little vanilla implementation here, but I'm curious to see what's out there. So argparse is yeah, just like Python's argparse. And so you basically define the arg parser and you give it the short description, the long description, the short tag, the long tag, and all that, and whether it's required or not. And you can see it's like just as much code to set up what we did by ourselves, and then you have to learn their whole little framework for arg parsing. And we don't have that many arguments. We're taking one argument. So don't really need something like this. But if you have like 20 flags and you take like 8 arguments, then I would definitely use something like this, a full-featured, fast command line argument parser for Rust. Clap. You want to get clap. You want to get the clap library for sure. Just kidding. Try not to get the clap. Okay, well, it looks like there are some out there, and they're pretty identical to what you see out there with other languages. So, okay. Just wanted to check that out. Ours is fine though. Okay, so now we've actually got the file name. Now we want to basically get the metadata for the file. Now we can actually start. Let's go back to the file. Now, here we go. So there's methods. We're in the struct file. On the left, you can see struct file. And there are methods, and then there are traits, and then there should be properties or variables. Okay, structs, functions. So, methods. Open, create, sync all. Metadata, there it is. I'm pretty sure that's what we want. Metadata. Examples. Look at that. Look at that beautiful example for us. So, oh, you can look at the run button. You can just press run. I guess, I mean, does foo.txt exist in this event? Yeah, no such file. Well, that's cool. That's okay. I was just curious if it would work. Okay, but Alt-Enter, import. I love the JetBrains magic. I'm gonna call it file. Now the OK. That's an idiom I'm gonna have to get used to. Just the line that says OK with the question marks at the end here. Okay, but anyway, what I want to do is print line, and then I think that's the debug symbol. And then we want to print the metadata. Like that. So now let's try out the program. Could not compile. What is it? Okay, it doesn't like my check arguments function. Hold on. Missing lifetime specifier. Okay, I'm gonna have to Google that one real quick. That's a Rust specific thing. No, what is this, Excel? What does this say? Let me be more clear. Rust. Oh, have I already looked up this question before? Oh no. Okay, saying an Excel-like data structure. This is the one I just opened up. Missing lifetime specifier means that in the struct definition, you haven't told it how long the reference to the string slice is allowed to stay around. In order for your code to be safe, it has to stick around for at least as long as the struct. So you need to define a lifetime parameter on your struct. Hold on. Let me try something. I think I did my syntax wrong up here. So now if I do this and I go back here and I do Alt-Enter, let's see. I had it working over here with where it was passing, yeah, with the string. Here we're saying get, unwrap, get, and then unwrap. And that should be a string. Hold on. Rust function return. Let me just make sure I'm not messing up the obvious function syntax. Yeah, so it is the arrow. The skinny arrow is how you return a value. And is it not a string? Is it? So yeah, expected string found at string, which is okay, which is not a problem. At least it shouldn't be. But it's telling me, oh, no, it says error, and then it says consider giving it a static lifetime. And static. I'm a little confused what they're saying here. Help, this function's return time contains a borrowed value. But there is no value for it to be borrowed from. Okay, I think it might have to do with... Let's see, so... file name as string is going to be that. And I'm just trying to kind of debug and make sure I understand what's going on here. Right, so when we unwrap it, it should become this. I'm surprised it's not red squigglying me and telling me that I need to say, like, let file name as string. Now it's kind of clarifying with the inline debugger here, or the inline code helper. It just says, this is an address to string. And so it's giving me the same error in the same spot. Is it the function that it's saying? Do I need to make the function static? Hold on a second. Static lifetime scope Rust. We got James. James Hagen says it is a string address. Try toOwned method. Dot toOwned, huh? Interesting. Interesting. There's no... I don't have a class right now. So it's interesting. It's saying toOwn needs a self, so it's like add self on the string, I guess is what it's saying, but then what type is it? Expected at string, found string. Okay, so maybe then I can just return a regular old string and it'll be okay with that. No, it's hold on, I got close. Cannot use the... Okay, now I'm getting a different error, so I think I made it past that. I think I made it past that one now. So I think we're good there. Thank you, James. Now, to make sure I understand what's happening there, I am going to do a quick Google search. I want to really understand what toOwned does and why that was being a problem here. A generalization of clone to borrowed data. Some types make it possible to go from borrowed to owned, usually by implementing the clone trait, but clone works only for going from an address of the type to the type. The toOwned trait... Oh, so because it was only returning the address, it was like, okay, well, after this function goes out of scope and is done, then that address wants to be recycled. So unless you transfer the ownership of that address somewhere else, then you need to do the static. So I think it stays static and becomes available in the whole context. But if you actually create a clone of it, and you create a whole separate copy and you return that one, you could say, okay, the one that I was just working on, internally, when I go out of scope, boop, just delete it, free up that memory, and let the calling function do whatever it wants with its copy of this whole thing. And so I think it's basically saying the owner is going to be the calling function who gets the return value. That's going to be the owner. That's going to be the new owner. I hope I understand that correctly. The toOwned trait generalizes clone to construct owned data from any borrowed data type. toOwned creates owned data from borrowed data, usually by cloning. Okay. Okay. Awesome. That's probably going to come up again. That's one of those things I anticipate I deal with probably a lot, so I want to make sure I understand that. Thanks again, James. So let's see. Now we've got the file name as a string, and I can probably clean this up now and just do unwrap.toOwned now that I understand. I hope so. So let's see. Oh, did I leave the foo.txt? Yeah, let me change this to the file name. And what was it saying about the question mark? Cannot use the question mark operator in a function that doesn't return anything. Or returns that. Help. The trait try is not implemented. No. Is it because... Well, that's interesting because that was the example. That was like the official example. So let me try taking them off and see what happens. Oh, was it because I took a little chunk out of it and didn't use the whole thing? Here it is. Oh no, that was it. I mean, it's... Oh, I guess they're saying main should be returning this as standard IO result. That's interesting. Does that mean it's gonna print out to the screen? Hold on. Let's add those question marks back. Now this one, expected results found blank. Now is the okay? No. Hold on. Oh, is this what it needs to actually return, is the okay? Okay, the OK is actually what it was returning at the end, I think. Let mute file, remove this mute. Mutable. Alright, this is looking a lot better now. Cargo run, and we'll actually give it a file name. So we'll say what? Cargo run, give us the information about cargo.toml. And it worked! Alright, success! Look at that. That is the metadata about the cargo toml. Okay, but that's not very nice to look at. So why don't we actually create a function called print metadata, and we will pass it the metadata, and we'll take care of printing it out in a nice function. So here we'll say fun print metadata, and we're going to take the metadata, which is going to be actually of type. Oh, the type is metadata. And I think we're going to have to import. And up top that did the standard file system metadata import for us. And then... Awesome. So now we can say get metadata for a file. And we'll say file name equals string, file open, metadata equals file metadata, and then print metadata. And this is where the last bit of logic is going to come into play. So what do we have? We have metadata dot file type dot this dot that. So I actually just kind of want to... Oops. So basically, the name... No, wait. I want this to go here. What do we have? The name, the file type. What else is there? Is directory? Is it a dir? Is file? Okay, we're gonna need more of these. Control D to duplicate lines. We've got what? Permissions. Alright, that's an important one to look for. Permissions. Last modified. Last modified time. These don't need to be capitalized, do they? Last modified, what else? Last accessed. Another important piece of information. Now these things can be modified. It's important to know that. And maybe one of the things we'll even look at is modifying timestamps, access times on a file to make it look like a future or a past date. So we'll look at maybe doing that too. Last accessed, created, looks like there's only a couple more. Error, kind, other, error. Oh, created is an error. Creation time is not available on this platform. Okay, that's fair enough. Okay, so let's try those. Now we have to come over here and say, well, I guess the file name is something we already have. Isn't it? We have the full name. Yeah, it looks like it doesn't have the file name itself, so we'll just use... Where is it? We'll pass it in. Print metadata, file name, metadata. And then in print metadata we will take the file name as a string in addition. So now we can just say the file name is file name, and then here this is file type. This one is dir. This one is file. Permissions. Ooh, what is this one? Modified. Accessed and created. And there's some extra dots here that don't need to be there. Okay, so now let's try this out, and we should have much better output. Value used here after move. Oh. Now, can I do this? And will that be considered a borrowed value? which means it'll just borrow it real quick. Borrow value borrowed here after move. Move occurs because file name has type string, which does not implement copy. Okay, so I think this is... See, it says value moved here. Okay, let me make sure I understand what's going on here. Because I don't necessarily want to make a to-owned copy. I do just want to let them borrow it for a second, because I am going to keep it within this scope. So Rust has a pretty interesting memory ownership model. I'm not complaining because it serves a very important purpose. Okay, so, but in fact, in many cases, move is good. I recommend reading up on move semantics because it's at the core of the ownership. Yeah, we looked a little bit at how to move variables. I forget, you just put... let me see, did I add anything in the README? No, I didn't. Okay, normally when I see that error message, I interpret it as meaning I forgot to clone the object. Excess cloning is, of course, a waste of resources, but it's often the easiest fix. And often the impact is negligible. Alright, well... Alright, that's fine. So what I'll do is do the same thing, and I'll just pass a whole regular string copy. Oh, did I... Let's see. Okay, do I need to go back to what I had before? No. Now hang on a second. Now how come it's not working here? So it says there's no clone. Well, maybe it does. Maybe clone is the better way to do that here. Hold on a second. Maybe now I can go back to just the string. Value borrowed here after move. So this is one of those things that every beginner in Rust probably deals with. It's interesting. Well, these are some of those things that make different languages interesting. Is the fact that, like, okay, this is a very important feature of the language, so it's going to take a little getting used to. You need to .clone it. Okay. Well, I am .cloning it now, right? So why? Let's see, why doesn't it like that? Well, yeah, see, I don't want to clone the address, I want to clone the actual thing. What am I doing up here? So, .toOwn to get the string, but I'm doing that on the ad, so maybe I need to do from the address do toOwned. Was that part of my problem? Okay, James says line 44 is the line taking ownership. So line 44. Oh. So this is taking ownership, and here it's like, hey, nope, I'm already owned. You can't have me. So do I need to copy it earlier before it gets used, or should I do the clone here and say, okay, send a copy to that one and send a copy to that one? Okay, because it's just the name, it's just a little string, so I'll just do a copy. Thank you, James. Second time you come in for a clutch save. Okay, so here we go. Now let's also print. I want to make it a little more. I like to use this formatting where you do the brackets at the beginning of every line, and on a success, you do a plus. The stars are just informational. A minus means an error. Metadata for a file. And why not? We'll just put a little line separator. Okay, let's try this out again. Alright, I like this a little bit better. It's a little clear which lines explicitly are the output of our program. We've got the name of the file type. Interesting. I wonder if there's something a little more human readable for that. Is directory false? Is file true? Permissions? Okay, we need to make that a little bit more human readable too. Last modified. Oh, I need to unwrap that one. The times are options, I guess is what they're called. So if we unwrap those, then we should get one step closer to them directly. Created is actually an error, which is okay. There we go, system time. Okay, so we want to convert those two. So let's go to the permissions object here in the Rust. So we've got, where was it, metadata. Now I want the metadata struct. Then I want to look specifically at the permissions. Okay, and I want to go to the permission struct here. And let's see what it's got. Read only. Basically, is read only. Is it read only? Yes or no? Permissions X. Let's see. I'd like to just print out the values like you see them when you're doing ls. Right now it's giving me something. See, it's giving us the mode 33204. That's got to be the decimal. That's got to be the decimal representation. So maybe we just need to convert it. So if we paste that in, let's go into programming mode. So that's decimal. Yeah, let's change it to hexadecimal. No. I want to see the hex. Oh, I guess it's octal. It's not hex, it's octal. Now, that's base 10, base 6. How come... Oh, there's the octal. 332. Wait, hold on a second. Go back to decimal, paste it in, give me the octal there. 664, there it is. You see how it says 100,664? That's the permissions like we see them in the Gmod or whatever. So what we want to do is convert decimal to octal. So that's going to be like a print formatting thing. Now we have here, so can we say, okay, hex, upper hex, octal, there we go. Oh. Okay, so let's see, permissions dot. Do I have to unwrap it? Or it's just dot mode? Let's try printing it out like that. Yeah, so I have to do It's one level deeper. So it's permissions, which is a permissions object. Oh, it's dot file permissions dot mode. Is that right? No, hold on a second. Go back to the permissions object. So we've got the permissions thing, and we actually want... Let's see. So let's see. Here we can see when it prints it out. We can see here it's permissions, file permissions, mode. So I really don't think this is it, but I'm just gonna try it just so I can say yes. Okay, it doesn't work. It's interesting because when I do the control space, oh yeah, there it is. So nothing like... Oh, you know what? It's probably because it's a list. So it'd be like the first one dot mode. No, but I think that's kind of why I'm having a problem, because permissions is a list. Okay, so why don't we print the type? We should be able to print Rust print type of object, just to make sure. And it's okay. No, so the struct called permissions is, oh, here we go. Unix specific functionalities such as bit mode, mode bits. That's what we want. The mode bits is available through the permissions ext trait. Unix specific extensions to fs.permissions. Example. Excellent. Permissions dot mode. Oh, it's a function, or a method rather. So that's why it's not a property and it's not finding it. Let's see. Metadata dot permissions. Permissions is that. Permissions dot mode. Metadata dot permissions dot mode. Let's try this. We'll say permissions equals that. Permissions dot mode. Just kind of a sanity check. Not found in this scope. Let permissions. There we go, we're making a little bit of progress. Oh, excellent. I think I just need to now include the proper thing up at the top. There we go. That's much better. So now we've got the value being printed out directly. And I want to print it out in octal. I don't think I can just drop in the O like that. What if I did just drop an O straight up? No. Hold on, I gotta check out an example here. So, print octal Rust. They had the formatter of the O. Oh, it's colon O, not O colon. Colon O. There it is. And so these are gonna be like, is it a directory? I think so. If we try it on the dot, yeah, now we can see it starts with 40 instead of 100 at the top. So that's going to be somewhat related to like the directory, and the last three are the file. So 664 is the file, 775 is the directory, and so we can confirm that, yeah, this file is 664, and the directory is 7. Yeah, so it's 7, 7, and then that's going to be 5. Cool. So that's human readable enough for me. But the modified time, I actually want to see some dates, some actually more readable dates. So this one too, actually, I want to... I'll come back to that one though. And we'll see. So it's interesting. We're at 50 minutes and still working on the first one. I don't feel bad though, because Rust is a very new language to me, and I'm learning a lot about the language, and these things like all of the unwrapping and the options and the ownership and the moving and the borrowing and the cloning. These are all concepts I'm still trying to solidify, and I'm just trying to get familiar and work my way around and get this stuff in my brain really well. So this has all been a really good exercise, and doing all this work to make sure we get the formatting right. This is all going to make the other ones go by much faster too, because we're going to be borrowing so much of the reference here. Like for printing hexadecimal, we're printing octal now, so this whole example of dumping a file as hex is going to be a breeze now that we know how to open a file and we know how to dump in hex and things like that. So the first ones are always going to be the slowest. And let's see. So what, the dates. Okay, we want to fix the dates. So let's run it. Hold on. I gotta fix my... Okay. So here we got a system time. And... So a system time elapsed. I bet they have... Oh, there we go, a format. I wonder... unresolved reference, interesting. I wonder if they have like if I just say print out as a string, does it have like a stringify method that's automatically going to... Oh, an extra parenthesis that I left by accident. No, wait, that's right. That one's needed, so... Oh yeah, it cannot be formatted with the default formatter. So let's say timestamp format Rust. No, I don't want to use an extra library. I just want to see... Okay, Rust system time. I want to see the actual documentation for this. Okay, so system time now, duration since, copy. Now those are just... Okay, so let's see, is there... I want to see if there's already a friendly function for printing it. Or if I just need to use some other method. Let's see. Let's see what they've got. No, I'm not seeing much. So when I do the code completion, it says that there's one. Oh, but that's on the result. So on the right, you can see what object is providing that, and it's the result. Let me just do another. Let me do another Google search here. Date, time, anything in here about timestamps? Okay, print Unix timestamp. Formatted Rust. Yeah, here's a Stack Overflow question. What's the... Oh, let's see. I'm not familiar with Rust. Okay, so Chrono. Okay, Chrono may not be like a third-party crate. That might be one that's built in. And if it's built in, I'm way more on board with using it. No, it does look like it is a third-party one, but that's okay. Let's go ahead and use it. So let's go ahead and add Chrono to our cargo toml dependency. And then using it, we have to put an extern crate up at the top of our file. Okay, let's put that up here. Let's put it way up at the top. Okay. And then use, well, we'll use whichever one we're going to use, whichever import we're going to use. So how do we format? Formatting and parsing. String from time. That's pretty much... Let's see, is that their special date time? Okay, how do we create a time? I think we're going to need to create a time object of their time from the timestamp. Okay, let me go back up to the top. So usage, add it. Okay, durations, date and time. Well, let's go back here to this one now. Okay, so you parse it. Yeah, so you get the timestamp and then you parse it. Create a normal date time. Well, we've got a system time, which I guess is probably a date time already. And then format it. Interesting. So let's see. Oh, does it have a format function already? Was it just having trouble finding it? Through the autocomplete? It's building? Well, it's building the dependency. Yeah, no method named format on system time. But there is on the date time. Let's see. Creates a system. Okay, so they're using a system time here, which is what we have. Okay, create a date time from the system time. That's where... That's the one I want. So let's try this. Metadata unwrap. So we're going to say this is the modified time. And then we're going to try and create one from the modified time, like that. And we're going to do Alt-Enter to do the import. And then we should see up at the top chrono date time. We're also going to import probably chrono UTC. Yep, there it is. And then from here we can say modified date time. Why don't we do this? Let's do it like that. And then we'll duplicate that for the other one. Metadata accessed. Accessed, and that's going to be the accessed date time. And then we'll format that one too. And hope that that works. Let's try it out. No, that didn't quite work. Delayed format. Oh, okay, so I'm gonna have to date and time plus the offset. So is there a .toString? Okay, that's what I was going to see. So that's going to create a format object, and then they have another function that will concatenate all that junk together. Hopefully, yeah, there we go. Now we get a nice, clean, and I think we can go away from the debug output and just go to regular string formatting. There we go. That's so much cleaner. Look at that. And now, is all that right? So, March 22nd, 23. So if we do UTC time, that's like 6 hours ahead, which would be 6 hours. Yeah, 426 on that date. Okay, so actually I want to be clear. So maybe we can say UTC at the end. There we go. Boom. Now it says UTC. I'm not going to bother trying to convert the time. Oops. Too many windows open now. Okay, great. So this is starting to look a lot better. Oh, we've got the created one too. I think that's going to be the same thing. So why don't we say created. I guess why don't we just shorten these? There's no need to make the name that long for all of these. Oh wait, I'm gonna have to do the format again too. And why don't we just copy the format string? Just in case we ever want to change it, then we only have to change it once. It's always best to reduce the repeating you do. Don't repeat yourself. Keep your code dry. DRY. Don't repeat yourself. Oh, let's see. Let me go back. Cargo cd get file. Metadata cargo run. And run it on cargo.toml. Let's see. I think I skipped a step here. It panicked. Oh, that's right, because this one doesn't exist. Now, how do I... Yeah, that's not what that does. So I guess... replace unwrap with a try? Can I just put like an arbitrary try catch block around it? I'm gonna need a catch. Is it catch or is it accept? Let's see, hold on. Line 47. Oh yeah, let's make it mutable so we can change it. So now dot unwrap. Oh, I guess it's because we have two different types here. I guess we want to do the whole, can we try? Let's not actually give it anything. There. Now it automatically... Awesome. Now it automatically goes, okay, well, it gets set to a datetime UTC later. So it's going to have to stay that time, stay that thing the whole time. and then I got my try, and then is it catch? Is it accept? Is it, hold on. Try catch rust. I would use options expect. Oh, okay. Okay, so options expect. So would you do dot unwrap, or I guess would you do dot expect? Okay, dot expect. And then this is what, I guess, your default, like if you don't get anything back. Hold on a second, what's this? Oh, I guess it wants... Now it's probably going to complain because the type it gets back. Yeah, because it's gonna. I think it's gonna end up sending back, or unless that's just like the error message. We'll say no created date available. Now, does that come out? Let mute. Oh, remove this mute. Yeah, that's fine. Panicked. Yeah, panicked. And then there's the message. Okay, so it's still panicking. Can I tell it to, like, not expect? Expect error? I want it to, like, expect or not expect. Unwrap or okay, so then we can give it let's see, or else op. Is that supposed to be a function that you're supposed to pass back? Closure. Yeah, so it wants a function, it wants like a callback, like what do I do if there's a problem? So in that case, is it just like that? Will we just say, or rather, can we just return no created date? Hold on, I'm doing this wrong. Yeah, I'm let's see, hold on a second. Unwrap or else. Let me find an example because I'm kind of flailing in the dark trying to figure out how to make a lambda here. I'm trying to like assimilate all my knowledge from other languages and assume that it's going to be something like it. But let me see here. Unwrap or else. Unwrap or else. Oh, okay, so then you just say... You don't need a function, now you just pass it the... Hold on, I think I have this all wrong. Control P, it wants the op. Hold on, so if I just put in a string, it should tell me like, oh sorry, I actually expect something else. And op, unwrap, or else op f, a function. It's a function. I just want to return... I just want to say like unwrap or... or none. Can I say null? Hold on a second. This is a little confusing to me. So what if we just do unwrap or a type? So yeah, the problem is I don't want to send back a date. I don't want to send back a default date because we don't know. If there's no date, then I want to return none or nil or 0 or something. So otherwise I have to return a date type. Yeah, expected system time. Let's see. So James was saying use expect, but see, I don't think I want to, because expect is kind of like an assertion, and it panics. So we'll say Rust. Oh, it's is empty is what it is, right? There's an is empty, so you can say. Wait, what am I missing now? Okay, so we'll do this. Dot is empty. No, is it over here before I unwrap? Is empty. Rust options is empty. Yeah, this whole concept of the options is like a very critical piece of the whole language, and it's unwrap or default message, but it was actually panicking, right? And I don't want it to panic. I just want it to okay. Sorry, I didn't mean to pop open data grip there. So yeah, dot unwrap or yeah, well, because it's not a string. It wants a default system time, but I don't want to provide it a system time. I want it. I want to check if it's none. Option empty. Is none? Oh, is that what it is? Now, do I need to... Yeah, I'm... Okay, so when you have metadata.created, you're supposed to unwrap it, but we don't want to unwrap it because it doesn't exist. Or rather, we want to do the or else and then pass it a function, but then we have to Rust lambda function. Closures, closure example, please. Oh, okay, so how about that? It's going to be the error. I don't really care what the error is, actually. So I wonder if I can just omit it. And that's going to be, just return NA. Yeah, so it still wants a system time. How can I, so I don't want to unwrap it then, can I check it? Like, where's the is none? If it's an option, is it not supposed to have the is empty or is none? because in here it says methods is none. But here it says no. Dot created. So it's like it's erroring out before it even gets an object back from it. Or, so what are these other options? Or, okay. Okay, let me just try this. Rust option check if empty. I'm not sure why I'm having such a struggle trying to figure out. Is it because I'm not even getting the option? So how do you print the type? I guess it's an error is what I'm getting back. And that's why I can't do anything like print or like is none. I can't do any of that because it's like, no, you're working on an error. You're not working on an option, you've got an error object. So obviously you can't is empty on my error. I'm not. Error cannot be formatted. Sorry, type isn't result. Got it, yeah, okay, so it's not a result. How do you print the type? Now this is interesting because it's like this comma that. I guess it's gonna be either one of those. Let me try the debug format. Cannot infer type. Oh. Yeah, let me comment that line out. And that one too. Okay, here we go. Yeah, so it's an error type. Okay, so then we could just say like, if metadata created is of type error. Rust check if type. Type, so what do you do? Type of type name? Hold on, how did Rust check if there is error? Result. Oh, maybe that's why. Yeah. So you're saying it wasn't a result, which was kind of why things were being a little weird. Because I guess that's what I was expecting it to be too. A result. Well, I guess it is a result. It is a result. So on a result, you can do these things, like you've got and then as self is error. Ah, there it is! There it is! Jeez. It took me a while to eventually get there. If metadata created is an error, then don't. Well, what we'll say is if it's not an error, then we will go ahead and then do the created time. So why don't we just pop that down here and say, hey, by the way, yeah, if this one is not an error and it does exist on the system, then why don't we go ahead and print it out? Alright. Alright, we're back in business now, I think. And I'll add a couple line breaks just for readability. Now let's go back and try it out. Hey, James and XXYZ. Thanks, guys. I really appreciate the assist. I think I finally got that finally got that part sorted out. And yeah, I do have an unused import now that I can get rid of. Now what about this one? Typo? Oh. Let's just go ahead and save that. Get rid of those squigglies. Alright, this is looking a lot better. So, actually let's do this. Where we have that, if it doesn't work, then let's still print a line just to be clear that the created date is not available. That, and there we go, a little error saying, yeah, sorry, there's couldn't get the created date, but we got the other ones, and we got the permission bits. Okay, now this file type is the last one. So what is a file type object in Rust? Let's see. Let's see, Rust file type. Here we go. Let's pull up the official docs. So I think my fundamental misunderstanding here was that this metadata.created was a result. And with the result, you can say is error and is okay. So a result. Results and options. Results and options. Got it. Okay, so file type ext. I want to see so the value we have here, where the file type, okay, I don't want the methods, I want the actual, okay, file type extension. Oh, so here's where we can see, is it a block device, is it a character device, is it a FIFO, is it a socket? Is it a symlink? Okay, so there's actually a whole bunch of information. There's a whole lot of information buried inside this file type struct. Yeah, so we've got those four. And then we've also got this one here. Is symlink dir, is symlink oh, those are Windows supported ones. So you've got two file type extensions, one for Windows and one for Linux. Let's see, why don't we go ahead and do it? Let's be thorough. And let's add, let's print out all of those. So this is just so that I can make sure I get each one. And so I should be able to do metadata.filetype. Yeah, and there they are. Is file, is dir. So we've got, yeah, is file. No. We want, we already did those. We want is block device. Now do I have to do, so how do I reach this file type ext? So I'm using the permissions extension over here, and I think all I had to do was actually import the extension properly. So if we just say that we need to use the file type extension, then will it basically let me start using those things? Can I start saying is block device? Let's just see if that works. One more parenthesis. There we go. Hold on. Oh, there's 3. Yeah, there's a couple lines that say type now. Okay, so this. Okay, it's working. Is block device. So we'll say is block device. And then we're going to copy that one several times. So there was what? Is block device, is care device, is FIFO, is socket, is symlink dir, is symlink file. Now these were Windows only, and the other ones were all Linux only. So those are probably going to throw an error on Linux. So we'll probably have to do some kind of is okay or is error. Symlink. Is symlink file. Here we'll say, is it a socket? Is it a FIFO? First in, first out. Is care device. Alright. Yep, errors. Interesting, so I wonder if we can... How would you wrap those? How would you wrap those and be like, hey, if they exist, or if they are Windows, or just like wrap it in a big arbitrary try catch to where it just says like, okay, no problem. Is there a try catch in Rust? I guess that's what I was trying to find out earlier. Oh, that's weird. R hashtag try. Okay. The question mark operator was added to replace try and should be used instead. Okay, so can I wrap them like that? And will they just kind of magically be like, oh, well, if we don't work, we don't work. Cannot use... Let's see. So, what's the best way? Rust check if function exists on platform? Yeah, I think this question's asking kind of what I'm doing. No, conditional compilation happens at the syntactic level before the information even exists. If you want a conditional compilation switch, you need to use a cargo feature or have a build script set up. Interesting. So alright, well, what I'm going to do for now is just comment them out and leave them saying Windows only. Oh, someone, let's see. Mr. X says, question mark operator can only be used if your function returns a result. Can only be used if your function returns a result enum with the same types as the function you're calling. Interesting. Okay, well, I'll leave those. If I needed to do a Windows version, I'll just compile it differently. But I think that was it now. If we fix those, awesome. So now we get block device. Yeah, we don't need to print out the general type anymore. So where we're printing out just the type, we can get rid of that. And I don't think there's anything that we missed on the file object. Yeah, is block, is care, is FIFO, is socket. Yep. Okay. So I think we're done there. Oh, you know what? The only... Well, I'm not going to do it now, but they do have a colorize. They do have... Oh, no, that was Crystal. I'm getting confused. Okay, so that's perfect. This is all, it's all good and it's working. Now, is there any refactoring I want to do before I close this file up? We've got check arguments, print usage, main, print metadata. What I'm going to do is actually just move the main down to the bottom. Okay. I think that looks good. Up at the top, I'll just add a quick little note that says print metadata about a file path. Get status. Let's see. Get status of Rust. What's the diff on the WebASM? Oh, I guess it just doesn't even exist yet. It's totally untracked. Okay, get status of this directory. Yep, sounds good to me. Git commit, we're gonna say adding the get file metadata program. Okay, cool. So the next ones should be a lot smoother, hopefully. And where are we at now? We're already at an hour and a half. So let's see. I bet we can get through a handful of these pretty quickly. I'm gonna go take a real quick break. Actually, I'll wait just a minute. I need to get some water and keep my back a stretch in a minute. Let's go ahead and get the next one started. Actually, let's do getting hex, dumping the hex values. So let's say cargo new, and we'll just call it dump hex. Sounds good to me. Dump hex. Dump hex. Okay, we'll go ahead and tell our project to use the cargo toml for the project that we're working in now. Okay, so we're gonna have to do some of the same things, like check the arguments and a print usage. So why don't we copy some of that code from before? Let's go ahead and copy the print usage and the check arguments, because we're gonna take one file argument the same way. Now, why is this one complaining? This function takes 0 parameters. I guess we're going to pass in the args, which is going to be the vector of strings. Oh, and print usage also needs. Oh no, so we don't need the we don't need this here, because that's going. What I need is here for the executable file name to be passed, which is a string address. Okay, yeah, and this one needs a return, and it returns a string. And the usage is going to be the same. We're basically going to dump hex. Okay. So now that we've got the file name, we're going to say let file name equal check arguments. And that's going to handle printing the usage and exiting if they don't provide the right argument. So, awesome. We can reuse all that. And then, now that we've got the file name, we want to basically open it, read it, and print it as hex. In this case, I think it's going to be like that. Rust string formatting. Here we go. Hex. Upper hex. I prefer upper hex, so X, like that. Okay. Now we'll probably want to print it out in chunks, like chunks of 2. So first we're going to have to open the file, and while there is still file contents, we're going to read 2 to 8 bytes and print as hex. Cool. So that's our pseudocode. That's what we need to do. So we'll say, oh, we've already got the file IO example, right? File IO here. So we already know how to create and write. Here we go. Read to string. Well, we don't want read to string, but we do want the file system. Rust fs. So this is the file system module, which will do things like let us create a file and open it, and then read it, hopefully. Yeah, read. Okay, so we're going to do something like fs file, and then create a new file with the file name, and then open it, and then we'll want to read, so basically say let open file okay, so I don't, oh, let's see, let's go into the directory, dump hex, cargo run. Oh, I need to actually print it some value, give it some values. Okay. Did you mean fs file? So do, yeah, I think I'll do more like that. Okay, so open looks like a static function, and it's going to return a result that's either going to be a file or error. So we could say if open file dot is error, then we can say exit 1. Well, hold on. Standard process exit. And we'll say print line unable to open file, and then the file name, which is file name. And oh, so I'm going to need open file dot unwrap dot read. Is that right? So I want the file. So unwrap should give me the result, right? Or is that an option, which is different? No, unwrap. And then read? How come? Oh, use standard io.read. I have to import that trait, is, I guess, or... Oh, this takes, let's say, okay, we want to, how about read 2 bytes? Expected, immutable, unsigned, 8. Oh, I guess it wants the buffer? It wants the actual buffer that I'm going to fill up, is that right? Yeah, so here it is, read, and you pass it the buffer. Okay, so let's do a buffer of 8. So we're going to create a mutable buffer. Now they had this weird notation, 0:10. Now I forget. Okay, so that's the size? Yeah, I think that's the size. Hold on a second. What is this called? Creating an array, Rust? Initializing an array. Yeah, okay, so it's the type and the size. And I don't want it to default to an int. I want to do that, and then I can say go ahead and read the buffer, which is going to read 8. Should read 8 bytes. Oh, what happened here? Oh, do I need to buffer equals? Expected, yeah, mutable U8. Yeah, that's... No, so what's going on here? So in their case... No, what are they doing? The @mute buffer, @mutable buffer. Let's see, Mr. X says, by the way, you can shadow open file after the if statement by doing let open file equals open file.unwrap. Since calling unwrap multiple times might be ugly. Oh, so you're saying like, unwrap it once and reuse it now that it's so that way I only have to unwrap it once. Oh no, I'm having I'm having some trouble here with this array, because oh wait, now it's understanding. Now it is smartly going, oh, this wants an unsigned 8-bit. Now it's being more smart. Okay, so now I think I know what I need to do. File name, value borrowed here. Yes, but you can reuse the same variable name. Oh, I see what you're saying. Yeah, I could do that. Just like open file equals open file.unwrap. Oh, but see, that changed it back. That's interesting. That changed it back to a U32. Interesting. Anyway, I'll just now I've got too many variable names, but that's okay. So hold on. If I compile it now, what is it complaining about? Oh, the file name. The file name is being borrowed. File name dot clone. Is that going to be better? There we go. No file name argument provided. Okay, we'll go ahead and provide it a cargo comma. Awesome. There we go. 1, 2, 3, 4. 4. Cat cargo.toml. Is the file itself just too short? No. And in upper. Oh, I'm actually printing out this value here. What I actually want to print out is. Let's see. So what I'm going to get back here, I'm going to have to unwrap or empty. Now how do can I just return an empty array like that? 0, 0. Let's see. How do I want to do this? So this here is going to be... Okay, so... Yeah, we'll say if it is okay, print out in hex the value, the data. Okay, I guess I'm gonna have to save it, so we're gonna say let data, and I'm gonna need that to be mutable because I'm gonna be changing it a lot. Okay, boom. I think that might do it. No. Oh, unused import. No. Should be a used import. Now this line can go away, so can that one. Did you mean print line with an exclamation point? Yes, because I'm very enthusiastic about my print lines. Okay, yeah. Well, I'm gonna have to do like a while loop. While. Now you can't just do like that, can ya? Now break, I guess that will break out, so we'll say if the data is not okay, then we'll just break out of the loop. Yeah, I'm okay with the infinite loop. Well, I guess we can say while keep running, why not? We'll just... And then here we'll just say keep running equals false, and then it will immediately break out of the loop when it hits the next iteration. Oh, there we go. It's gonna keep coming back. Okay, but I guess what we want to say is data dot length dot size. Well, I guess we want to unwrap it and then check the size. Is this another case where we can just say no, it needs a new type, so we'll say unwrap data equals this, and then we want the size of that. It's a U size. Oh. So it's actually, it's not the data we get back, it's the buffer that actually has our data. So actually what we want to say is not if data is okay, because the data is always going to be okay. What we want is data.unwrap is going to be the length. So we're going to say if data unwrap equals 0, that's when we'll also say keep running equals false. So if there is an error, end of file, or it's not pulling any more data, the length of bytes read is 0, then we're done. Otherwise, we want to print out the buffer, which is where our data is going to be stored. Upper hex is not implemented for U88. Interesting. Okay, so we can print out 1 byte at a time. Okay, so I think we basically want to iterate through, or can I do like this? Can I say buffer from 0 to 8? Oh, it's dot dot, isn't it? Yeah, I think that's how you do it in Rust. Standard format upper hex not implemented for U8. Rust print buffer as hex. Oh wait, there was earlier. Yeah, I saw a hash. Maybe that's for arrays. No, hold on a second. Let me go back to Rust bump strings. Here we go. Upper hex. Oh, okay. The alternate flag hash adds the 0x in front of it, so I don't really care about that. I guess what I want to do is like concatenate it all. I wonder if I convert it to a vector of bytes, if that will help at all. No, upper hex not implemented. Hold on, let me try print upper hex array. Rust, how do you print out an array here? Someone filed an issue on Rust. Upper hex trait should be implemented for U8. It would need to be format. Interesting, let me see. See if anybody offers a workaround or something out here. Otherwise, I guess you'd have to like loop through it yourself and be like, okay, well, for each buffer dot for each, go through each one. This allows multiple types to be formatted via X. Okay, so okay, they're just like C loops. So we'll say for I equals 0, I equals less than the buffer length, I plus plus, and then I don't want to print a line. I just want to print with no thing. Buffer element I. What is this? Expected plus plus? I'm confused about what it's complaining about. Add got a semicolon, but it was expecting something else. Oh, it's Rust for loop doesn't look like a C loop. Jeez, I should have read like one more line. Yeah, so we want for I and 0 all the way up to buffer length. Now, is that going to be inclusive or exclusive? Okay, it looks like it's going to be what we need here. X buffer of index. Alright, no, and not print line, just print. Okay, cool. And then at the end, I want to print a space. And I want to break it. Well, no, I don't want to do the line breaks explicitly. Oh no, so what I want to do is I want to do that after all of them are printed out. There we go. So now I actually want to lower the size. So instead of reading 8, I'm going to read maybe 4. No, that's still too much. 2. That's okay. So now we got 2 byte chunks at a time. I suppose printing the space between each one wouldn't be so bad. And then you could break the lines how you wanted with your terminal. But why don't we... Yeah, why don't we break it after every 8? So we'll say column, let mutable column equals 0. And then here, every time we print one out, we'll say column plus plus. And then if column is greater, let's see, it's going to be greater than 7. Column equals 0, and then print out a new line character. Hold on, it looks like I messed up there. Okay, awesome. So now it's not printing out the leading zeros. So I wonder if I need to put the 0 in front. No, let me go back to the format strings. How do you get it? Rust print leading 0 in hex. Yeah, so it says put the 0 in front. With the number of zeros. 0, 1x? No, that didn't do it. Hold on. How do you do it in hex? There's nothing else about leading zeros. Upper hex. Okay, the upper hex trait should format its output as a number in hexadecimal with A through F in uppercase. Yeah, I don't want the 0x in front of everyone. I guess we could, if there's not a format way to do it. Then I suppose we could just do this. If the value of the number is less than 16, then we'll just go ahead and print the 0 because we know that it's only going to be a single digit. So basically anything up to A will be a single digit, so there. Now we just prefaced it with a 0, and everything is coming out nice and clean. 8 bytes per row, 1, 2, 3, 4, 5, 6, 7, 8. And it's all coming out in hex. Awesome. That looks beautiful. Let's try. So this is the hex dump of our source code. Cool. Okay, let me clean up, do some refactoring. Any refactoring I want to do? I think it looks okay. The main function's a little long, so can we break that up a little bit? Let's see, open the file and get the file. I'm going to put the variables all up top so that they're together like that. Not all of them, but just some of those. Okay, so then we get the file, and this is there's some comments because this is kind of yucky. Exit infinite loop once, no more bytes to read. That's what that line does. And this one says this is for printing the hex. Print the hex values. Okay. I think that's okay. That looks good to me. I'm gonna go ahead and commit that code. Let's run it one more time just to make sure that it's looking good. Alright. Git status of this directory. We'll see, adding dump hex example. Git push. Alright, so as you guys could tell, writing the second one was a bit faster than the first one. Just because of all the work we did in the first one, so much of it we were able to leverage and kind of reuse. Plus, I'm still getting familiar with the whole language as a whole, so still learning some of those basics, and I really, really appreciate the help from Mr. James and Mr. X in the chat, who gave me some good pointers and helped me a little bit when I got stuck. So the next thing would be like, yeah, check the byte value, and if the byte value falls within the ASCII range, print it out as the ASCII character, and things like this. So we're already at 2 hours. Now I'm gonna go ahead and call it for the night. The goal was to see how many we could do in one sitting, and it looks like we only got these 2 done for now. I do expect that the other ones would go much faster now that we have some reference code to work with, but for now, that's all I'm going to do. These code examples are up online now, so if you go to devdungeon.com, or I'm sorry, github.com/devdungeon, then you go into the cookbook and you go into the Rust folder, you will see the dump hex, and what was the other one we did today? Get file metadata. So those files are all in there. So here's our dump hex, and here is our get file metadata. Alright. Well, the last thing I'm going to do before I sign off is my plugs real quick. So subscribe if you're not already subscribed, so you can check out the daily live streams. youtube.com/devdungeon. Go to github.com/devdungeon for all the code examples. Go to devdungeon.com for all of the blog posts and tutorials. And if you're not already on the Discord, go to devdungeon.com and then go to join me on Discord in the right column. Click on that and come hang out and chat. And buy a few copies of my Security with Go book. Other than that, I really appreciate the chat and the help and everybody who came out. I will have some more streams where we finish the rest of these tasks. But for now, I'm going to call it a night, and I'll see you guys tomorrow.